Welcome back to the channel, guys. So, starting a new series to solve the GFG problem of the day solutions. So, let's look at the today's problem that is known as string count. So, the problem here states given a length n, count the number of strings of length n that can be made using A, B, and C with at most one B and two C allowed. Let's head over to the note section. So, we have been given a number n and we are asked to make output number of strings. String's length should be of n, and it can comprise of A, B, and C. B can occur at most one time, and C can occur at most two times. The problem is fairly simple. Do not need to complicate it. If you have studied PNC in class 12th, I say, or 11th, during the JE preparation, you might be well versed with the problem of PNC. So let's consider the case that n is equals to 0. In that case, number of possible strings is 0. Obviously, if there is no length, how can we fill in any character A, B, or C? If there the length is 1, only 3 characters can be made. It can be inserted B, C. The answer would be 3. For length n equals to 2, how many can be made? First of all, AA, no B and no C. AB or BA using 1B. AC or CA using 1C and 1A, or BC and CB. You can check on yourself. I don't think there is any other allowed. Yeah, sorry, CC also, because there were two C's that can be used. So the total number is 1, 2, 3, 4, 5, 6, 7, 8. For n equals to 2, it would be 8. Now I use n equals to 2 because they were at most 2C allowed. So in the further process for n equals to 3 and onwards, I don't have to complicate the matter much. So for that case, for for uh, for n greater than equals to 3, we have three positions left. It can come with A. So the possible cases are we are not using any B or any C. We are using one B and not any C. We are using 0B, 1C. We are using 1B, 1C. We are using 0B, 2 Cs, and 1B, 2 Cs. It can be possible for all the strings we have to make in the future for n is 3 onwards. Okay, so the first case, there is only one string possible, all comprising A. For the second case, it would be, now here comes the PNC part, n factorial by n minus 1 factorial. Total number of characters factorial by the number of repeating characters factorial, which is equals to none other than n. Similarly, for this one, n factorial by n minus 1 factorial, which is again n. Similarly, for this one, n factorial by now there are only n minus 2a is present. So n minus 2 factorial, 1 factorial that is equals to 1, so it would be n into n minus 1. For this case, it would be n factorial. Now also n minus 2 a's are present, n minus 2 factorial. But here comes the additional term of 2c because 2c's are also identical. So 2 factorial. It would be equals to n into n minus 1 by 2. For this one, now because of 1b and 2c, if the length was total n, minus 1 for 1b, minus 2 for 2c, n minus 3a's are present. So the factorial sum would be n factorial, n minus 3 factorial, and for this 2c, 2 factorial term will also come. So it would look like n into n minus 1 into n minus 2 upon 2. Can you guess what the final answer would be? The final answer would be the sum of all this term, that is 1, n minus 1, n minus 2, n minus this one. I hope that's clear. Let's head over to the code section. So yeah, we identify the base cases as n equals to 0. In that case, we have to return 0. Else if n can be equals to 1, in that case, we have to return 3, a, b, and c. Else if n equals to 2, we have to return 8. The cases we identified, that is AA, AB, BA, AC, CA, and CC, and BC, CB. Okay. Now the story afterwards is fairly simple. We have to make for room for 0B and 0C, 1B and 1C. Oh, sorry. Okay, yeah. 0B and 1C, 0B, 1B and 1C, 0B and 2Cs, 1B with 2Cs. For the let's declare a variable here, long and answer equals to 0. For 0B and 0C, answer plus equals to 1. For 1B and 0C, answer plus equals to n. We discussed n factorial by n minus 1 factorial. For 0B and 1C, answer plus equals to n. Again, n factorial by n minus 1 factorial. For 1B and 1C, answer plus equals to n multiplied by n minus 1, because the number of phase would be n minus 2 here. For this one, n star n minus 1, but extra divided by 2 because of two identical c's. For this one, answer plus n star n minus 1 into n minus 2, because of n minus 3 is present, divided by 2 for two identical c's. Return the answer and just hit the compile button. Let's look at our answers. It is running for uh, the test case, sample test case provided. Let's try and submit it. Hope it works. It works. Thank you for watching the video. Please don't forget to like and subscribe the channel. See you in the next video tomorrow.